processes. So it's just a tool for me, for at least in this course. But if you really want deep into it, and you just need to explore more, okay, by yourself. Okay. All right. Now, so now the other thing that was probably, so we have done matrix, we have probably vectors and matrices, we have finished. Now plotting. Okay, so plotting is a very uh, important part, and I hope some of you already know it. So, for example, how do you plot? Well, plot, it has a command called plot, and let's say x comma y, where these two would be an array of this, basically a vector of the same size. Okay, so it would be like a data points x1, x2 up to xn, and y1, y2 up to yn. Okay, so basically this would be x, this would be y, and each x1, x2, x3, x4, x5, etc. You will get a, this is the way MATLAB draws a plot. Okay, so now suppose I have to plot a function. So if you have these arrays already made, then you can plot directly by giving this command. You have to ensure here that they are the same size, right? Because for each x there's a y. If you have a function to plot, so this would be plotting an array. Okay, so an array. Okay, plotting a function. How do you plot a function? So, for example, uh, let's say I need to plot fx equal to, let's say fx equal to uh, exponential 10x into x minus 1. Okay, if I need to plot this, then what do I do? Basically, I need to construct two arrays. One would be with x, one would be with fx. Okay, so let's construct that. So how do you construct array in MATLAB? For example, let's say x is going to vary from point 1 to 1. Okay, suppose I have to plot in this particular range. Okay, there's always be a finite range in which you want to plot. So or maybe 0. Why 0.1? Let's say 0 to 1. This should be 0 to 1. Okay, so in this range I have to plot this function. So I construct an array which would, I have already told you, automatically there would be this kind of command, this kind of command. Okay, it's an inbuilt kind of syntax in MATLAB that will automatically create an array ranging from min, which is 0, to max, which is 1. The values will range from this range, and the step size would be the central value. Okay, this is the step size. So this would automatically create a bunch of values, 0, 0 0.005, 0.01, and so on, okay, up to 1, okay, and stored in a vector called x. Okay, so you have already created your x range. Okay, now at each x, I need to calculate the value of fx and then store it in an array, right? That's what I want to do. Okay, so I need to calculate the value of fx at each x. How do you do that now? Well, so to do that, basically we can just write this as y. Let me call fx as y. Y would be equal to, what I need is exponential. The function that is given is exponential 10x into x minus 1. Okay, so how do I do that? Can anyone tell me? I have to write it like this, and that is where you have to be careful. 10 into x, and this is product anyway, star x minus 1. Okay, and that's it. Okay, is this correct, by the way? Can anyone tell me, is this correct? This what I've written here, if I give this kind of command, will I give the correct answer in MATLAB? Yeah, no, that's right. You have to have, because you have to do it element by element operation, right? So you have to do x dot over here. Okay, all right, and okay, and x minus 1 is fine, and this entire thing has to be yeah, so there should be a dot here. Let's try this. Okay, let's try this. So now let me go to MATLAB and check this. Okay, and then once you have created this, then you will have y array made, hopefully, and then just give the issue the command plot x comma y. Okay, so this arrow means return. This would mean return. My notation, this means return. Or hit the enter key, basically. Okay. All right. So let's see. This is a, can everyone see the MATLAB window? Okay. Thank you. So let's do this. Let's say I'm going to type in x equal to 0, 0.0051. Okay. And if I just have to give a colon here, because if I don't, then all the x values will be actually outputted on screen. Okay, so I'll just give it like that way. Okay, and then just a second. I have a class going on. बाद में बात करते हैं. So okay, then y equal to exponential 10 into x dot into, what was that? X minus 1. I guess that is correct. No. Okay. So when you issue CLC, that is clear console. So you just clean it up, right? So CLC is for clear control. All right. Now let me see, what did I get here? So I'm just hitting up arrow key so that I can recall the previous command. So y is 10x x minus 1. Okay. Okay. And plot x comma y. If I just issue this command, plot x comma y, I should get a picture or figure. It's taking too long, I suppose, because there's so many points. I can reduce the number of points by increasing the number of steps, the step size. Let's wait for a while. Let's see. I think I have missed a dot here. Let's see how it appears, but I think that's not the way it should be. Way too many points. Some error. Low level graphics error. Let me just do this again. Let me make the X array maybe 0 point. Just take 10 points. Okay, I have this, and Y. I think यहाँ पे there should be a dot over here, because when I multiply this element by element, and then I have to take the element by element. Okay, no, sorry, not here. I think that's fine. Should be all right. Let's plot again. Uh, Mriga, you have a question. Yeah, I think, okay, so I'll come to your question. Just a minute, let me wait. Why is it not plotting? Uh, why is it not plotting square? Just a second. No, there's something wrong with the graphics output here, I guess. Let's check the values anyway. 10x, when x is 0, that will be 1. When x is 1, that will be 1. So endpoints match. And there will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, just this central value should be the minimum. Yeah, central value is the minimum. Okay, so this looks to be correct to me. Why is it not plotting? Well, it should plot, and it just does open a window, but yeah, it should be. I think in my system there's a problem. I think there is a problem. Yeah, yeah, yeah. Fine, fine, fine. That's good. So if you are getting it, then there's a problem. Yeah, there's a problem in the graphics of my system, I suppose. I'll have to check with IT people now. I'm sorry about that. I did not foresee that. I did not see this coming. So, but yeah, this is correct. Okay, fine. All right. So this is okay. Now over to the question of Brigaya. I think you had asked. Explain the difference, significance of x dot star next and not. Okay. So yeah. Well, if you so basically when you give this command, x is an array and x star x minus 1. Let me say where x is an array. Okay, let's say it's either a column array or row array. Okay, either way, this now if I give a command like this, we had discussed this will not be accepted because use of this requires that this is an operand and this is an operation, and these are the operands actually on which this operation occurs. So this particular this star operation, when done on non-scalars, which can be vector or matrices. So if these entries are not symbol numbers, okay, if it's a number then it's a simple product. But if these are not numbers, then you require them to be compatible in the sense that it should be if it is n by m, then it should be m by l or something. So if x is uh, n by m, then well, let me write it this way. So if you require this to be okay, a star b, then a is, let's say, m by n, then b should be n by l. So these two must match. Okay, these two must match, otherwise this operation will fail. Okay, there's a constraint on applying this particular operation. Okay, so this will fail. So here x minus 1 is also an array of the same kind. Okay, so that would be, let's say, n row by 1 column or 1 row by n column, and this is also 1 by n. So 1 n by n and n by 1 and n by 1 cannot be operated by this uh, uh, basically what you want here is you want to multiply these two arrays element by element. Okay, you want to multiply this element, so you have x like this, and x minus 1 will also be of the same kind or the same kind like this, whichever way you have defined it. So this, and you want to multiply basically this entry with this entry, this entry with this entry, and this entry with this entry, and so on. Okay, so that for that, doing that, you want actually this dot to appear there. This dot star, this particular operation is basically implies element by element operation, element by element product. Okay, and here you have to ensure that these entries match. N by 1 is this also n by 1, this also n by 1. Okay, okay. And you remember, so I had discussed these cases earlier. So remember also that if you had to take a dot, if you probably take, if you make a dot, well, maybe we need to go to the next page and remind you of the result that you expect for, so results expected from star operation. Okay, so here, so let's say I have, uh, let's say this star, this. This will fail. This should fail, I suppose, right? This and this, that would lead to a scalar, which is actually a dot product. Why is it? What happened? Why is my pen is having trouble now? Okay, so dot product. What I mean to write is a dot product. Okay. Okay. If you do this way, let's say, if you do it like this and this, okay, what do you get in this case? You should get a matrix. Okay, so that would be n by 1. Am I right? So n row 1 by n, n by 1. Yeah, so n by 1 and 1 by n. That would give me n by n matrix. Okay, so that should be results, right? This would fail. But suppose I wanted to do element by element product, then I can use, so this dot star this. This will not fail. It will give me element by element product. Okay. All right. I don't want to spend too long on discussing MATLAB actually, because there are more important things to be covered. So it's not the part of this course. But still, I have to do it because, um, well, this is part of the course in a way. In a way. All right. So next. So you have done plotting. There are multiple ways to do that. There is one. So if you have to plot a function, there is one other way. There's another way to do that. That is called easy plot. Okay. So how do you do that? Let me just remind myself. I have to check my. I don't use that very often, but that's also a good command to remember. It's called EZ plot. Okay. Um, let's see what that was. That easy plot I had somewhere in my list of useful commands. Easy plot. Acha, by the way, I think that issue that we encountered in the last lecture has been resolved. Okay, because remember when you give EIG, when you try to calculate EIG, it only gives the when all with the possibility when all the eigenvalues are positive. Please check that link that I sent to the class, right? So I guess there was no confusion about that. If anyone is still having confusion, please let me know. Yeah, should be here. Okay, so now plotting, there are some more things about plotting. Okay, you can actually do multiple data can be plotted, multiple uh, uh, pairs of arrays can be plotted. Meaning, if I have, let's say, A and B, I want to plot this correspondence, and another pair C and D, okay, and I want to show these two on the same set of axes, okay, then all you need to give is plot, and let's say this is X and this is Y, this is A and this is B, okay, so you just give X comma Y comma A comma B, okay. So if you give it this way, if you a command like this and hit enter, you should get a plot of these two trends on the same with the same axis, okay. You can also plot, for example, if you have a one set of independent, let's say these are X, and there are many possible curves, let's say Y1, Y2, uh, Y2, and so on. So so I want to plot for the same set of X all possible Ys. So I want to plot this pair and this pair and this pair. So that can be done by giving, uh, this would be like plot X and a vector. This would be a vector X, okay, and this would be a matrix of small y's, right? So if you, this a capital Y will be basically a matrix which you form by taking all these row columns and make a single matrix of all of those. Okay, so that way you, if you make a matrix of all these y's, so you will have one as one vector as x1, x2, and other matrix will be, let's say, y11, y12, y21, y22, and so on. Okay, then this will plot this versus this row, then this versus this, sorry, not row but column. So this column, this column, this column, this column, this column, and so on. So okay, so that would be multiple plotting with the same x's. Okay, all right, and so these are about the, if you had these arrays already built in, or already defined, or the data is there, then you can plot them, right? But if there is one way of plotting another way of alternate way of plotting a function is using uh, ez plot, right? So ez plot, uh, that is, the command is, so this is for some, this would be for user defined functions. Okay, and here I do not have to actually uh, construct arrays. Okay, so ezplot does not have to construct arrays and then give plot x and y. All you need to do is you have to give a command that looks like this. I'll just tell you what it means. uh, okay, so this is a function that you have defined. Okay, if you defined a function, already defined a function which takes an argument x and a is some parameter. So if I, function that I must have defined. Okay, and actually, if you see here, this function is there in the same folder as the file named read initial profile.m. So let me open this. So this is another. So this is my original uh, driver file, the main script file, which will be actually executed. And this main script file calls this particular function, for example, okay, which I have over here, okay, and it does simply start with function, ends, and there's a control loop for end, etc. These are the arguments, input arguments. Output is G, okay, and G is basically output is a array, okay, which is returned by just doing this calculation. That's all, okay, very simple. So that is my function which I frequently call. So therefore, I have stored it somewhere, and every time I need to call it, I'll probably use. I'll just issue this command called read initial temperature profile, okay, and here, for example, here I have this thing appearing, right? So now let me say if I give a help and read initial temperature profile. Oops, sorry. Uh, so let's see. Hold on. Oh, I see. Did I issue a wrong command? Oh, right. You're right. Thank you. Maybe that's the reason. That's the reason, maybe. Initial temp profile. Yeah, so here, there you go. Thank you, Jangir, Rohit. Thank you. So yeah, I was giving a temperature profile, but it's not a function available. Okay, so yeah, you see that this echoes this output. This function assigns initial temperature profile. If you look at this file, which was initial temperature profile, you see that the line right next to the function definition which appears after percent has this statement. Okay, so this statement will be actually displayed on your console when you issue help function. Okay, all right, thanks very much. uh, and you can also have for example, you can have this something called sub functions. Okay, so you can have sub functions and nested functions. Okay, so you can have sub functions. So what do you do in what do you mean by sub function? The same function file may contain multiple functions. Okay. So for example, uh, so a function may call some other function which is specific to itself. Let's say, okay. So function one, let's say function number one calls again. It needs to when you actually depends on design of your call code, how you have moduled it. So function one may have to may call some function uh, two. Okay, so in that case, the same .m file, okay, will contain function one, all everything over here, and this in this definition, the function two will be called, right? So in the same file, you have function 2 defined separately, okay, after function 1. Okay, so when a function 1, basically this function 2 is in the scope of this function 1. Okay, meaning this function 1 can call this function 2. Okay, that's a scope. So this is under scope of this. However, this and also you can it can also it will so remember, okay, one very important thing here is the file name of a function file the same as the function itself. That is very important. Do not make this mistake. File name of the function file, okay, is the same as the name of the function. Same as the name of the function. What do I mean by that? Well, So for example, when you saw this, when I have read initial temp profile, okay, this function, this is the dot m file. When I'm saying this dot m, that would mean it's a script. Basically, it's a where is that file? Okay. So this is my read initial temp profile dot m. That's the name of the file which contains the function definition. But at the same time, the function name is also the same as the which is read initial temp profile dot m. So apart from the dot m, the name of the function is also have to be this. Otherwise, there will be an error. Okay. So when you call a function in main script, which is for example over here, when you call this function, okay, MATLAB knows that I'm going to look into a file which starts with the same name. Okay, which has a file name that reads as this dot m. Okay, that's a very important thing to remember. If you make this mistake, the your function will never be found by. So if you had stored this function, whatever you have written up here, if you store it in a different name, then when you call this over here, you will never find it. Okay. And here I can also define other functions. For example, I could have probably here other, I could have defined function, okay, h equal to something something. I don't know. I'm not going to do it. I'll just change it later. But what I just for the sake of this explaining this, so I could have done this, okay, and then I could have called this whatever name I give to this particular function, okay, over here, which does not match with the name of the file, by the way, okay. So this function can be called by this g function, okay, the read initial temperature profile function, okay. So inside this body of the function, I can call the other function, which is defined after this particular function, okay. So this would be called sub function, okay, and this will lie in the scope of this particular function, the main function, okay, which is the file name itself, okay. So this will lie in the scope of this, but other, so you cannot call this function from in other script which is not in the same file, right? So main script cannot call h here, but g can, this function can call h here, okay. So I hope that is probably clear. Let me not do this. I hope. Okay. All right. Okay. And all right. So, and then there is something called nested functions. Okay. So, um, and then something known as, maybe I can just write this. How much time do I have? Okay, I still have 15 minutes or so. All right. So you have sub functions. I just, okay. So this, basically, a dot m file may contain other functions. Okay, so this may contain other functions. Okay, called sub functions. Okay, so which may appear in any order, which may appear in any order. uh, so that would be after the main function, basically. After the main function, it can appear in any order, so it doesn't have to be particular order, but they are basically being called. Okay, this is visible too. So this under scope of only the main function. Only the main function. By main function, I mean the main function is basically related to the file name. That would be the main function. Okay. So I think that is unambiguous. Okay. And there is called something called nested functions. What is a nested function? You can have one function, okay, And then when you're defining it inside itself, you can define another function. Okay, so this would be a nested example of nested function. Okay, what is the use of this? Well, whatever variables you have actually over here, the main function, let's say parent, you have a parent function and you have a nested function. Whatever variable you are using here, they are also accessible to the nested function. Okay, so the variables, or technical way of saying this, that the workspace of the functions, variables of the root function are accessible. Meaning if I have defined x equal to 10 here, let's say, then when I do this calculation in this function, whenever I can call x, this would be automatically taken to be a value of 10, which is not inside this function. But since it's nested, so this considered in the inside the parent function. Okay, this is the nested function. Where this was not true over here in the sub function, that is not what happens. So if you have function 1 uh, and then function 2, okay, and here you define x equal to 10, and if you write x here, this will not be automatically equal to 10. Okay, in if the function 2, okay, this may have some other value whenever you use x here, right? So these variables are not under scope of this function. Okay, the function is in scope of this function, but the variables are, or the data of the function are completely secluded, right? There's no relation between the data that you use over here versus data that you use over here. So that is the sub function. But in nested function, that's not what happens. You can actually access the data of the root function in a nested function. Okay, so the variables of root function are accessible to the nested function. Okay, so that is about nested function. Now I want to move on to some. So we'll start. So now a lot of things that we will learn. We learn how to implement a lot of numerical methods using MATLAB and model a particular problem. In this context, there are quite a few things which are already inbuilt. All right. However, they are okay for smaller scale of problems. For bigger scale, I won't recommend using the inbuilt functions of the MATLAB, right? And it's better to build your own code, implement your own designed algorithms, okay, etc. But for quick checks, okay, for small problems, it's always a good, very convenient to use inbuilt functions in MATLAB, right? So maybe I can just say some numerical methods in MATLAB using MATLAB. Using MATLAB inbuilt functions. Okay, so first thing that we have seen so far is, for example, we have seen finding roots of a function. Okay, roots of an expression, complicated, a nonlinear expression. Let's say. So in that context, let me start with this thing. MATLAB are have a very easy representation. Okay, have a very convenient representation. Okay, what do I mean by that? Well, so what I mean by that is that suppose p of x is a polynomial of nth order, that would p1 x raised to n plus, let's say we call this, the p1 and p2 have a particular meaning. Okay, so pn plus 1 is the constant, and p1 is the highest. So you have to remember this. This is not like p1 is not the x raised to 1. P1 is the highest coefficient, the highest order. Okay, and pn plus 1 is a constant. Okay, so it's a constant. In that way, you have arranged your polynomial. Okay, that's the way you have to basically arrange it. Okay, if you arrange it this way, then um, if you so then these numbers, if you store in a row vector, let's say I'm going to define a row vector. Okay, in my MATLAB. So this is basically this is maths. Okay. Now I'm going to MATLAB. Okay. In MATLAB, let's say P is equal to uh, P1, P2. Let's say I define a Pn plus 1. Okay. So this represents this any row array or column array. This represents also represents a this can taken to represent a polynomial, the above polynomial. Okay, so that's a very convenient representation of a polynomial in just row vector, in form of row vector or column vector. Okay, so this is a way to represent this particular polynomial. Okay, and if I want to find out what is the value of this polynomial at any x, okay, what do I do is I give a command called polyval defined over here. Okay, so this p will be used once you have defined p, then this p will be used to find out the value of the polynomial, which would be constructed from this formula. Okay, so p1, where x will be taken the value that I have given. Okay, so this will give the polynomial value at chosen x. Okay, um okay, now x can be also a matrix here. So you can also issue command like polyval p comma some matrix A. A is a matrix. What would it do at that in that case? What it's going to do is basically A is has, let's say, A11, A12, and so on. For each A11, A12, it will calculate the value of the polynomial at each of these entries. Okay, so it take, for example, x, whatever the number was, so this number is taken to be each element of the matrix A, and then polynomial value is calculated, and then it constructs another matrix again. Okay, so this will also be a matrix. The polyval P of A will be the element by element polynomial evaluated. Okay, so all elements are evaluated in the polynomial values, when substituting for x the corresponding element and then evaluating this function and then placing it over that particular relative respective entries. So that's a matrix. Okay, where each element is a value of the polynomial. If I give a command, for example, polyval m, now polyval m, okay, you can guess that what that would mean. Well, this would mean basically, so this would mean in place of x, now I'm going to have a, right? So P1 a raised to, where a raised to n has a very specific meaning now, okay? So in this case, this has to be a square matrix. If I'm using m here, then it has to be square matrix so that a raised to n can be obtained, okay? So a2, P2, a raised to n minus 1 up to Pn minus 1. Okay, so this is when I am using m over here, this would be evaluated. That will also be a matrix, of course, but the constraint is that A should be a square matrix over here. Okay, okay. Then you can also calculate something called roots of P. Okay, so roots of P would give me, suppose I calculate roots of P and suppose I call it x. Okay, then that would imply that P of x would be equal to 0. Okay, that's what the roots of, and this is very useful, for example, when you are actually looking at the compressibility equation that we discussed. Well, the equation of state expressed in terms of compressibility equation, in terms of compressibility like beta z plus gamma, that is equal to 0, where z was equal to pv by rt. Okay, then you can actually direct, this is a polynomial. Okay, and you want to find out when this happens, you have to find the root of this polynomial. So you can define a polynomial function by choosing these coefficients. What are the coefficients here? 1. Okay, so I define p equal to 1 alpha, not comma, 1 alpha, beta, and gamma. That will be my, that is representing this polynomial. And then roots and all this issue the command roots of p. That would give me all those z values that will satisfy this particular equation. Okay, so that's where it will be useful for you to quickly implement and find out what the equation of state predicts, right? Okay. Um, Next, let's say, yeah, the characteristic polynomial. For example, if you have command polyval roots, next useful command is poly, just poly. Okay, so if I have p equals to poly, let's say, let's say some matrix or vector. Let's a vector z. Okay, this would be a vector, or it can be actually a matrix also. Okay. So let's talk about the vector first, matrix itself. Just talk about the matrix. So I think let me just change the notation. I'm calling it matrix. Let me call it capital letters. Poly B. So B is a matrix. Okay. This give me basically P will be represent. So here this will give me P will represent the characteristic polynomial of B. Okay. And suppose you constructed this and then gave the command root of p. What do you expect this to give me? Any answer? Suppose, actually, there are some questions. How will the MATLAB understand that p is a cubic polynomial, not an array? Okay. So, well, no, that's a good question. It will take it as an array. It will not understand it's a this will be an array information provided, supplied to the MATLAB. Okay. It will just going to store it as an array. However, when I issue the command, okay, when I issue the command like polyval, okay, and when I issue the command, then it understands this. Okay, I'm going to interpret these entries in context with this array. Okay, so MATLAB will store it like a simple data structure is simply an array. But when I issue this command called polyval, then it's going to consider, oh, the user is wanting me to use these information to construct a polynomial and evaluate the value of the polynomial at that particular x. Okay, so that's a very good question. So it's not going to differentiate between whether array that I have given is whether it's a polynomial or not. No, but when I issue this command, then interpret it as if you are going to use it as a use that information in context with a excuse me, polynomial, right? So that is Rohit, does that make sense? Okay, thank you. All right, so next one. Okay, so root. Now tell me what. So now suppose poly p is a polynomial which is a characteristic polynomial. Okay, of b, which is obtained by giving this particular command poly b. Then if I give roots of p, what will that give me? This will give me actually the eigenvalues of b, right? Because the roots of the characteristic polynomial are nothing but the eigenvalues of the particular matrix, right? So for example, let me go back. Uh, so show, let me get rid of these two function files. Okay, okay, all right. Now let's say I define a function. Let's say I define a array, and maybe good old one, 1 2 3 4 5 6 7 8 9. Not a great array, but okay. Let me just you find out its eigenvalues by issuing the command. Actually, it has a zero. So let's this. Maybe zero is a problem case. So let me call it. Let me switch the positions of 1 and 9. Okay, so let me switch the positions of 1 and 9. Okay, I'm just going to switch these two. So that would look like 9 here and 1 here. Okay, let's see. Okay, A is this, and then eigenvector. Okay, that looks like all right. It has a negative value, but for our this case does not matter. Now, okay, so this I know that this matrix has eigenvalues given by these numbers. Okay, let me do it now. Let me go to the poly command. Use the poly command. Let's say I give poly of A. Okay, that will be this matrix. Okay, what is this? This tells me basically that my polynomial function looks like the characteristic polynomial looks like sorry, looks like lambda plus minus 15 lambda square minus 18 lambda cube plus 3. I'm sorry. I'm sorry. That's not correct actually. I just wrote it wrong. Okay. To be careful. Lambda cube minus 15 lambda square minus 18 lambda plus 320. This would be your determinant of when I expand this matrix 2, 3, 4, 5 minus lambda, 6 and 7, 8, 1 minus lambda. If you take this and just take the determinant, you will get this. Okay. And then when you put that equal to 0, when you put that equal to 0, I will get eigenvalues lambda 1, lambda 2, lambda 3, 3 eigenvalues. Okay. So let's try to do that. Okay. So these okay. So now if I give roots of well, I have not stored it yet. So let's say I'm going to store uh, q equal to poly a. Okay, so this is my q vector. Okay, now if I give roots of q, okay, I'm going to get these numbers 14.7494 when I had the same numbers which I got it by issuing the command eiga. So these are essentially minus 4.53843 and 4.7848. Okay, so these are essentially the eigenvalues, right? So this is an alternate way of finding the eigenvalues, but it's also it has more applicability in addition to finding eigenvalues only. Okay, all right. So that having said, now okay, I guess we can stop now. So yeah, I think we can stop. Okay, so tomorrow we'll meet again. Any questions? No questions. Then I can stop. Okay. All right. So we'll meet tomorrow again. And bye bye now.